This is 7.3 Part B. What we're going to do is write a rule for the nth term of the geometric sequence that has the two given terms. So actually we've done this already with arithmetic sequences. We're now going to do it with geometric. So we're going to set up our equation just like we've done before, and we're going to say this is the equation that we're going to follow for each one. So if I set up an equation for this first one, our n is going to be the 1, and we have a1, and we don't have an r, and then of course the n is 1. So we're going to say 1 minus 1, and we're going to set up an equation for the a to the 5th one now. Same format, except for n this time is 5. And what I'm going to do is I'm going to simplify these both because we have a number that we are given. So 1 is actually going to go here. And I know what 1 minus 1 is, and that's 0. And then down here we have 625. That's going to be plugged in here. So 625. And then I know what 5 minus 1 is, and that's to the 4th power. Instead of doing the elimination method like we did with arithmetic, we're actually going to do substitution method. So we're going to solve for a to the 1st power here. So we're going to take this equation. And if I do the math, I'm going to do it over here. We want to get the a to the 1st power by itself. So if we divide by r to the 0 on both sides, we now know what a1 is. It's 1 over r to the 0. We're going to take that, a1, and we're going to plug it in for a1 in the second equation. So we have 625, and our a1 is now 1 over r to the 0, and then we still have r to the 4th. Remember, that's on top technically, and we just need to simplify this. Remember, when you're dividing something with the same base and they have exponents, you subtract. So this is really going to be 625 equals 1, which who cares about the 1, 4 minus 0, which is still r to the 4th. And now in order to solve what the r is, we have to take the 4th root in order to cancel out the 4th exponent. So we're going to do the 4th root of 625. And of course, when we do the 4th root of r to the 4th, that cancels. And we're going to plug that in our calculator, and we're going to get 5. Now remember that when you have a 4th root, you have a plus or minus in front of your answer. Okay, so now you just found your r. And so when you're writing the rule out, all we have to do now is write a1, 5, n minus 1. Or we can say a1, negative 5, n minus 1. Both of these answers are correct because we have the plus minus in front. Now you're probably wondering, how do I figure out about the a1? Because we do need a number there. But because you have what r equals, you can take that r now and plug it in to either one of these equations. It doesn't matter. So I'm just going to do the top one. So if I plug in 5 here, and it doesn't matter if it's negative or positive because either way it's raised to a 0, and that's going to equal 1. So a1 is still going to be equal to 1. So we're going to write a1 as 1. So there's the first rule. Or that rule right there will also work. So here's the final answer, and I know it's a lot of work for one problem, just like the arithmetic was, but once you do it, you'll get the hang of the pattern to do it with. All right, now, just like with arithmetic series, there's a shortcut rule when you're trying to find the sum. And so I want you to realize that this equation is the sum of all of your patterns or your series, all the terms in them. And this is the rule, so we need to remember that rule. And we're going to find the sum of the geometric series. So here's our example. And just to point out, and you might want to copy this down, that's going to be your n. We already know what I equals. This 5 will always be the A1 according to our general formula. And we know that this is our R. So if we set the formula up, we need to plug in numbers for everything that we see here. So our A1, well, that's going to be 5. Our R is 2. And the N is 10. And we're going to divide that by 1 minus 2 again. Now, when you simplify, this is where it becomes a little tricky. You need to first figure out what the exponents are in here. So 2 raised to the 10 power is 1024. And of course on bottom we can start with that. We have 1 minus 2, that's negative 1. And now we can keep going. We have 1 minus 1024, which is negative 1023. And if we divide that by negative 1, it actually is a positive 1023. And the last thing you have to do is multiply it by 5. So the answer ends up being 5,115. And so the sum of this entire thing using the shortcut method is 5,115. And if you did it the other way, you would have to plug in 1 for I, 2, 3, 4, 5, all the way to 10, get all of those answers, and then add them up, which is fine. You'll get the same. It's just a little bit more work.